Remember in the last video we discussed the experiment of pulling two cards from a deck, and we counted the number of possible outcomes. This was 52 times 51. We're going to generalize this a little bit. Let's consider the experiment of pulling all of the cards from a deck. And now we want to know how many possible outcomes here. Well, we could continue on the pattern. We know the number of outcomes for the first stage, which is pulling the first card, and the second stage corresponding to the second card. The third stage follows a similar pattern, and there are 50 cards left after I've drawn the first two. And we could continue this through all 52 stages of this experiment of pulling all the cards from the deck. And this translates over into a calculation that looks like this. The number of total ways is just 52 times 51 times 50 times 49, etc. This ends up being about 8 times 10 to the 67th. Pretty huge. But this is an important concept, even if it doesn't appear so in the card example. It'll come up quite a bit in your real-world probability applications that you're interested in. And so it's got a name. It's called factorial. And the idea of the factorial is it's the number of ways to order n items. And it's denoted by an exclamation point. And as you see in general mathematical notation, n factorial is equal to n times n minus 1, etc., all the way down to 1. So let's see another example where this can come up. Let's say you have horses A, B, C, and D, and they're racing, and any ordered outcome is equally likely. And we want to ask the question, how many possible outcomes are there? So let's write out what happens. So remember, we want the possible outcomes. And so I'm going to break this up into different stages. And the first stage corresponds to the horse who comes in first. Now at this point I can think about this. There are 4 different options. Any one of the horses could come in first. But after I've chosen the first horse, there are only 3 that could come in second, that I could choose who come in second. And for third place there are 2 left, and the fourth place is whichever horse is left. And so now I have the number of total possible placements or outcomes of this experiment is equal to 4 times 3 times 2 times 1. This is 24. And we can use this to ask a couple of probability questions. First, what if I wanted to know the probability of the event B, C, A, D, where here this stands for horse B coming in first, and then horse C second, horse A third, and horse D coming in last. So just as we've done in previous videos, this is only one outcome, and so the probability is 1 divided by the total number of outcomes, 24, or about 0.04. One more question we can ask, now a little more complicated. What's the probability that horse A comes in first and horse B second? Well, now I want the probability of more than one outcome. I could have A first, B second, and then C and D in this manner, or A first, B second, and then I can swap D and C. Both of these are outcomes of interest for me. And so in this case I have actually 2 outcomes divided by the total of 24, which is about 0.08. We talked about this could be a sequence of 4 stages, and we looked at the probability of the ordering B, C, A, and D, as well as this more complicated question that horse A will come in first and B second. And these have been a couple of examples where we've used the concept of factorial.